So for the second video here for chapter 10 and looking at sections 3 and 4, this is a lot of the same concepts that we just did in the first video, but realistically this is the way that you'll do it. You're going to use a calculator, and as long as you can use your calculator, the only other thing that you got to be able to do is interpret what you have, and so that's kind of the main idea here. But one of the things that we dealt with in the last lesson was how closely related the data was. And so we said strong positive or weak negative, things like that. Now you can base that based on the look of your scatter plot, but we can also base it on a calculated value, and that's what we call the R value, or the correlation coefficient. So we use the letter R to represent the correlation coefficient, but it's based on that number that we can also determine just how strong the relationship is between the data points. So there's some good info right here, but let me show you something even better. If you look at this diagram right here, so let me start with the green chart. So if you can kind of see right here, if we get an R value that is really close to 0, we simply say that there's not a linear relationship if R is close to 0, whether it's a little positive or a little negative. If it's that close to 0, then we just say there's no linear relationship there. So here would be an example. Here would be an example of that, right? We can't even tell whether this is positive or negative. It's so spread out that we can't determine a direction. Therefore, there's no linear relationship within that data. If it's not linear, you can't say strong or weak or anything like that. No positive, no negative. If it's not linear, it's simply not linear. You can't give it any other description. So here's another example of something that we can definitely see there's a relationship, but because it's not a linear relationship, that's all we say is it's not linear, and there's nothing more you can do with it if it's not linear. But the closer R gets to 1, the closer R gets to -1, the stronger it gets. So the other way to say that is the farther from 0 you get, the stronger the relationship is. So -1 would be a perfect linear relationship going downward. This would be a perfect linear relationship going upward, which we tend to not get those. But you can kind of now gauge your response based on this green chart. So if it's somewhere between 0.8 and 0.1, we'd say that's a very strong positive relationship. If it's kind of in the halfway mark, it's moderately strong. If it's less than half, but not that close to 0, then we'd say it's weak. And so here's a couple examples of what those would look like. So here's 0.9. So that's right within this category right here is 0.9. And so we'd say that's a strong positive relationship based on that if it's 0.9. So, but this becomes a way of doing it without having to look at a graph. When I get this number in my calculator, I can now give an interpretation like this without having to graph the points. And so it's important that we know how to interpret what the R value is telling us. And so you're seeing on this screen a pretty good range of examples for how we would answer this question. So here's kind of we either call this weak or moderately strong negative relationship. But remember, you always give it 2 names, and everything you're seeing in this chart has 2 names. So we always say whether it's positive or negative, as well as the strength, right? And so there's always 2 names when you're describing the relationship of your data. So going back to that, so again, you can see on all these examples, there's always 2 names given, right? So positive or negative, and then the strength of the data. If it's super close to 0, then we just say it's too weak. There's not a correlation between those data, or it's not linear. All right, so here comes all the calculator stuff that you really need to know for this unit. First things first, we're going to start by creating a list 1 and list 2 within your calculator. So take a minute and do that with me if you want. All right, so I went ahead and put those into list 1 and list 2 in my calculator. Here's all the main info that you're going to need to be able to do with this. So here's my calculator. So if I went to Stat and Edit, hold on, let me help you see this a little better. So there's the 2 lists of data that are in my calculator. So we created those lists. Now if you go back to Stat and go under Calc, there's two areas you're going to want to know for this. One is the two variable statistics. In here you will find what we did in the last video by hand with the mean point. So if I go into my two variable statistics, I have my list 1 are my x's, list 2 is my y's, my frequency list is empty, and if I go under calculate, I can now find the mean point. The mean point of the x's is 55. The mean point of my y's is 120.4. That's my mean point. And so that's the main thing that you would get from the two variable statistics. So you have the average of both points. Also, if you go under Stat Calc, option 4 is the other one that you would use. So you're only going to use options 2 and 4 for this unit for bivariate data. The linear regression line, there's one key feature to this. There's two things that you get out of the linear regression line page. And that is the regression line that we just did in the last unit. We did this by hand, but you're always going to do this on a calculator. So if I plug in 5.60 for A and negative 187 for B, then I have my regression line. There's another thing you're supposed to get on this page, and that's the R value. That's the correlation coefficient. If it's not showing, then you have to go under Mode, and you have to turn on your stat diagnostics. You have to make sure those are on. Here we go. So those are now turned on. So now when I go into my linear regression option, now I'm going to see the R value. So there you go. So we do have an R and an R squared. We don't really use the R squared. We just use the R. But that's so you can see 0.939 would be our correlation coefficient. Super close to +1. So we're getting a very strong positive relationship on this. Remember to always use 3 sig figs for all this. So that's why I said for A value is 5.60, my B is negative 187, and R is 0.939. You always want to use 3 sig figs whenever you're doing those things. But that's where we're going to get all that info. So that's where we got the regression line from. And again, these should all be 3 sig figs. So we got the regression line, we got the correlation coefficient, and we can now use those things to interpret the data. So again, if they ask you to interpret the R value based on this, we would say it's a strong positive or very strong positive. We can now do some interpolation or extrapolation by plugging some numbers into our regression line. And so if they said estimate the weight of a 60-inch long bear, so they're giving me a length to sub in for X. So we plug that in, and we're going to come out with the estimated weight. Remember that if you use a data point that is inside the range of your data, then it's interpolation and it is appropriate. But if you use a number like 60, you can see 60 is definitely within the range of our data. So that's interpolation. So we would say, yes, this is appropriate. If something like 130 pounds is way outside the range of our data, so we would say it's not appropriate. You can still estimate the length. If this were a question on an IB test, you would still sub in 130 and you still give an answer, but they're going to ask you, is that an appropriate answer? And then you would say, no, it's not, because 130 is outside the range of my data. Notice it is based on the X that you sub in. It is not based on the Y result that you get. It's based on the X that you're using. One more thing on this. If you have to create your own, draw your own linear regression line, don't do what we did in the last video by hand. Do it with this line right here. There's two things that you must include when you do a regression line. One would be the y-intercept. So I should show that my line goes through negative 187. So I would have made this bigger. And I would show that my line goes through, hits negative 187 on the y-axis. That's my y-intercept. I would also make sure that it goes through the mean point that I got from my calculator. So there's 2 points you can make sure that it goes through, and we'd all have the same line. So it's got to have the same y-intercept and go through the mean point, and then we'd all be looking at the same line. So use those when you're going to do a regression line. Don't do it by eyeball. So here we go on this one. Again, if you want to take a minute, you can sub those numbers into your calculator. But simply, I'm just going to talk you through the results that you would get from your calculator. So again, I'm going to plug those into my calculator to get all the same information that you get here. And again, everything should be to 3 sig figs. So all that's coming from my calculator. So now if we said, okay, let's estimate a 6-month-old. So that's 0.5 years. So I'm going to use a 0.5 years. Sub that in, and we can estimate the amount of sleep that we would get if we were to sub that in. And this is always going to be more accurate if I'm getting these numbers from my calculator to 3 sig figs, not by hand. This will always be more accurate, and so you're always going to use your calculator to do stuff like this. Here we go. Let me mention one more idea again. If you were asked to draw a linear regression line, 2 things that you would want to make sure happen. It should go through this number on the y-intercept. So I would start at 14.5. So I would make sure that I hit this point right here, and I would find the mean point from my calculator and go from this point through the mean point and then draw the line. It doesn't matter if you have an equal number of points above and below the line, as long as you start here and go through the mean point, you'll have a perfect linear regression line. All right, last part on this, and again, this is where a lot of the points come from, is interpreting the data. So please hear me on what I'm going to tell you on this. What does the gradient mean? Right? The gradient means in this sense, remember the gradient is this number, y equals mx plus b. This is your m, or your slope, or your gradient. Gradient recognizes rate of change. This is the comparison of y to x, y minus y over x minus x. So I'm comparing the y information to the x information. If it's 6.04, well, that means that I am 6.04 dollars to every 1 crate of fish. And so that's the interpretation of the gradient. It's the cost in dollars to the crates of fish. What does the b value represent? That's your y-intercept. That's the initial cost that you would have. So it's automatically going to cost me $289, even if I don't sell any crates of fish. Remember, R is not gradient. So there's a big difference between what R means and what your gradient means. So make sure you know the difference on those. So the gradient compares your y to your x, right? And it gives you a rate of change, whereas R tells you how linear the relationship is between your data points. So again, some estimations on stuff like this. Why would it not be appropriate to estimate costing 20 crates of fish? This is your answer. Real simple. 20 is not within the range of my data. So look right here. The lowest point was 34. So 20 is not within the range of my data. So that's why it's not appropriate. Right here, they're talking about estimating the number of crates in order to make a profit. So again, we had our profit equation that we had up here, or our selling equation, sorry. So this is what it cost us. So it's going to cost me $289. It's also going to cost me $6.04 for every crate of fish that I sell. So that's important that you know how to interpret this. So if this is how much it's going to cost me, if I'm going to make a profit, then the amount that I sell, $14 each crate, so $14 for each crate, is going to equal how much it costs me. So my sales would equal my cost, then I would break even. If I solve for X, this is what I'm getting. So I need to sell, remember that's just for breaking even. If I'm going to make a profit, I got to sell more than that. And so if this is my break even point, I got to sell at least 37 crates in order to start making a profit. So interpretation of this stuff is really important for a lot of the questions that you'll be asked and getting all the points for this stuff. If you have questions, please come ask.